Hello, welcome to this video where we're going to be looking at something called a histogram, which is a brand new type of graph that has its advantages and disadvantages, and I'm going to be showing you how you can get numbers from a histogram that's already been drawn. You're not going to be drawing your own today or working them out, just working with histograms which are fully completed and go from there. So what is a histogram? It's a graph. It's used for displaying grouped data, like a frequency diagram. So if you think back to year 8, when you first did grouped data, you had frequency diagrams, which looked like a bar chart, but without the gaps. And you had a frequency polygon, which was sort of a dot-to-dot line graph. So those were the two graphs you were shown in year 8 for working with grouped data. Well, this is like a frequency diagram, so it's got bars, and the bars are stuck together. There's no gaps in between, but where we're different to a frequency diagram is that on a histogram, the groups could be different widths. So normally when you've got the group data, you'd go like 0 to 10, 10 to 20, 20 to 30, and every group would be the same, 10 wide or 5 wide, whatever. On a histogram, quite often they're not equal widths, and that gives us a problem with how we're going to display it in a way that is accurate and fair. So if you have a look at this graph, it doesn't really matter what it is. For the lower values, the bars are reasonably tall, so it looks sensible to have these groupings. So I'm happy with this frequency diagram. That looks okay, that looks okay, that looks okay. But then we've got some empty columns, and then we've got a very low value, and then another empty column, and then another low value. So what we say with a histogram is, rather than having all of these empty, we kind of say, well, why don't we take these and convert them to sort of one big group. So if this went 0, 5, 10, 15, 20, 25, 30, 35, 40, now depending on what you want to do, you could group the 25s to 40s into one bar. You could even go from 15 to 40 and have one sort of mega bar, if you like. But what we're trying to do is to avoid having graphs with tiny bars or even missing bars, and that's why you would have some groups bigger than others. So if there was a band playing in the CIA, I would expect that most of the people in the crowd are probably ranging from 15-ish, maybe to mid-30s for the large portion. And so my bar graph might look something like this. So in those age ranges, I've got lots of people, but as my ages go up, I wouldn't expect there to be many people in their 60s and 70s, depending on the band, obviously. And so if I tried to draw a group frequency diagram, a lot of those ages are going to have hardly any bars or no bar. And so I'd say, well, why don't we just say that everybody over 40 all goes into one group together, even though that's different to the other groups. So here we've got a frequency diagram on the left and a histogram on the right. So if we had a frequency diagram, to work out how many, you look at the height of the bar. And so on the left, you would say that this bar, say that's 8 and that's 10. You'd say, well, which group has got the most people in it? Oh, the second group has. It's got 10 people and the first bar's only got 8 people. But then you could also say, yeah, but hang on. There's 8 people in a group that goes from age 5 to age 10. There's only 10 people in a group which goes from age 10 to age 20. That's not fair. That, of course there's going to be more people. Looking at these widths, look, this one is 5 wide, this one is 10 wide. But there's not twice as many people in it. If these bars truly were equal, if there's 8 people in the first bar, shouldn't there be 16 people in the second bar? And so you could argue that there's not really more people in the second bar, even though there is. 10 is more than 8. Of course it's going to be more if you're including more ages. If I put on a bus, if I group everybody into age 0 to 10, and then everybody who's over 10, of course there's going to be more over 10s. And so that's not really telling you very much. If you've got a massive group and it's got more people in it, well, yeah, it's a massive group. So when we make histograms, we don't say the height of the bar is where we get our information from. What we do is we adjust it and we say that it's the area of the bar that is going to tell us how many. So what happens now, look, that first bar has stayed the same, but the second bar's got a lot shorter, but it's got more area. So this time on my frequency density, the area of this one would be 8 and the area of this one would be 10. So why is it so short? Well, because it's very wide, it doesn't need to be very tall. Okay, but that's fairer because now we've got something called frequency density. So this new phrase up here, frequency density. Now, if you do population density in geography, that means how many people there are per area. So it might be the number of people per square kilometre. Okay, for a large city it would be high because people live in tower blocks, whereas in rural mid Wales it would be low. Well, frequency density is very, very similar. What we're saying is how many people are packed into the bar, and if the bar is very tall, what we're saying is there's a lot of people in that bar for its size. Okay, so it's a 5 to 10 bar and there's 8 people in it, so that is more squashed than putting 10 people in a bar that is 10 wide. Okay, think of it like a room. Which room would have the most space? 10 people in a big room or 8 people in a small room, and how tightly packed in you are, that's called frequency density. But the main thing that you need to learn from this slide is that on a histogram, if you want to know how many, you look at the area of the bar, not the height of the bar. And that way we can do things a bit more fairly when some bars are wider than others. Okay, so if you can make sure you've got all of that in your book before we go any further, especially this bit here about histograms being the area, not the height. Okay, here's a histogram then, and it's measuring the length of something, maybe the height of a plant or something like that, okay, or the length of a twig, or the length of somebody's hair, it doesn't really matter. So we've got all different bars of different widths, and we're going to work out how many people there are in each bar and how many people there are or how many things there are in this survey. So all you've got to do is find the area of the bars, and they're all squares and rectangles, so this should be easy. So the first bar has got a frequency density of 1, that's how tall it is, and a width of 20 because it goes from 0 to 20. So it's 20 wide and 1 tall, so there are 20 items in that bar. 20 things, 20 people, whatever it is. For the next bar, it's 1.5 tall, and it goes from 20 to 30, so it's 10 wide. So even though this bar is taller, there's less people in it. But because the bar is thinner, they're packed in more tightly, and that's why the bar is taller. Okay, putting 15 people into a bar that's 10 wide is more squashed than putting 20 people into a bar that's 20 wide, and that's what frequency density is telling us, how tightly packed they are. But the first bar's got more area because there's more things in that first bar. The third bar is too high, and it's 10 wide because it goes from 30 to 40, so 2 times 10 is 20. So there's the same number of people in the third bar as the first bar, but because the third bar is thinner, it's got to be taller. They're more squashed in that third bar. There's a lot of people between 30 and 40. Okay, and then the last bar, it's only 0.5 tall, but it's from 40 to 60, so it's 20 wide. So actually that's got the least people in it. Okay, there's not many people, and they're spread out between 40 and 60, meaning they're not very squashed in that bar, so the frequency density is very low, only 0.5. So if I wanted to know how many people or how many things were in the survey then, so the total number or the total frequency is a good word because it means how many, is 20, add 15, add another 20, add 10, so what's that? 65. 65 items. Branches, twigs, plants, doesn't really matter what they are. Okay. If the question said, how many of these branches are less than 30 centimetres tall? That's easy because 30 centimetres is the first two bars, isn't it? So they're less than 30 centimetres tall and so are they. So in this survey, 35 of the things are less than 30 centimetres tall, and then we've got 30 which are bigger. Okay, so you can add up sort of just some bars and not other bars. You can even split bars, which we'll have a look at in the next question. So if you could draw that, get that into your book just as a really basic example of finding the area and the area telling us how many. And what I'll do, I'll put up here as well that less than 30 centimetres is 20 add 15, so 35 items. Okay, so those first two bars, the ones highlighted in yellow. Now there is a big assumption with a histogram, and that is that the 20 people in that first bar are equally spread from 0 to 20. Now we've had this discussion with box and whisker before. In reality, all 20 people could be down here, all 20 things could be down this end. Okay, but it's equally likely, I suppose, that all 20 dots are at the other end. You don't actually know what their values are from this graph. That's the drawback of grouped data, is you don't know exact values, you just know what group they're in. So they could all be down one end, they could all be at the other end, but to make our lives easy, what we actually assume is that all 20 things are spread perfectly evenly throughout this bar. Okay, so there's a dead even split all the way across. So if you asked me how many were less than 10 centimetres tall, we would assume that it's exactly half of them, and so 10. Alright, that's not necessarily true, it's a big assumption we make, but it does make our life easy that things are equally spread within the bars. That's more than 20 dots, I got carried away. Okay, let's have a look at another one then. So this is the age of people on a bus. It goes from 0 up to 60. And then because I'm maybe not expecting so many pensioners on the bus, look, I've grouped everybody from 40 to 60 into one group. Whereas in some of the younger ages, they're very thin groups and there's a lot of people in them. And I can tell there's a lot of people because the bar is very tall. So first question says, and you'll need to draw this in your book. So pause the video if you need to. When you're ready, we can do the question together, or you can have a go on your own first and then see if I agree with you. It says how many people are on the bus, so I need to find the area of every bar and add them all up. So we've got a bit of decimal work here, and we can even add on sort of the in-between numbers as well, so 25, 35, 45 and 55, and up the side here, look, we've got 0.1, 0.3, you don't need these on necessarily. Right, first bar then is 0.4 tall, so 0.4 times, and how wide is this bar? It goes from 5 to 10, so it's 5 wide, so 0.4 times 5. 4 times 5 is 20, so 0.4 times 5 is just 2. So there's 2 children on the bus between the ages of 5 and 10. Looking at the next bar, it's 0.8 tall. The bar goes from 10 to 20, so it's 10 wide, so the area is 0.8 times 10, so 8. So there's 8 people between the age of 10 and 20 on the bus. Then we've got our most tightly packed bar. Now we've not necessarily got the most people in, but because it's so thin, they're tightly packed in. So it's 1.2 tall times 5. Now 12 times 5 is 60, so 1.2 times 5 is 6. So it's not the most, but it's a very thin bar. It's only half as wide as the one before, so it needs to be a bit taller. Bar 3 then is 0.6 tall it goes from 25 to 40, so it's 15 wide. 0.6 times 15, so 6 times 15 is 90, so 0.6 times 15 is 9. So that's actually the bar with the most people in, but also it's the second widest bar, so it doesn't need to be very tall because it's already so wide, so not very densely packed. And our last bar is 0.2 tall. It goes from 40 all the way up to 60, which is 20. 2 times 20 is 40, so 0.2 times 20 is 4. So it's the shortest bar, but part of the reason is because it's so wide, it doesn't need to be very tall. So how many people are on the bus? So we've got 2, add 8, add 6, add 9, add 4, so 10, 16, 25, and 4, there's 29 people on the bus. Okay, how many of those people are under the age of 20? Well, they are the 2 children between the age of 5 and 10, and so are they. So everybody I'm colouring in yellow now is under the age of 20. So how many people is that? 2 add 8 is 10. So there's 10 people under the age of 20. I don't know their actual ages, but I know they're all under 20. Now the third question here is a little bit trickier. It says, how many people are over the age of 30? And what you'll notice is that 30 is actually part of the way through this fourth bar here. So how do we find out how many people are over the age of 30? Well, the easiest way is to get rid of all these things. I know you can't do that, but maybe you can just sort of put an arrow in and add on a dividing line. So I'll do it in red and I'll do it dotty. So I'm going to put a line down there. And now I'm going to say that, I'm going to do some colouring like I did last time. I'm going to say that these people are over the age of 30. So those and these people are over the age of 30, aren't they? So there's definitely 4 and whoever's in this sort of part bar. And the easiest way to work out the part bar is to basically start again and say, well, just for the bit that's coloured in pink, what is its area? So it's 0.6 tall. It's now only 10 wide from 30 to 40. So 0.6 times 10 is 6. So remember, the whole bar a minute ago was 9. So what we've done is we've split this bar, 3 on the left and 6 on the right. Okay. Is that accurate? Probably not. Because it could well be that all 9 people are between 25 and 30. And they just happen to be in the 25 to 40 bar. It could be that all 9 people are over the age of 35, and so really I should be doing 9. But we don't know, and so we assume that they're equally split and equally spread. So we've got 3 on the left and 6 on the right, assuming they're equally spread. So how many people are over the age of 30? So it's these 6 and these 4. So 6 add 4 is 10 again, just by luck it's the same as the one before. Okay, but that's just to show you that you can split a bar and calculate the area of part of a bar if that's what the question needs you to do. Now, what's really important underneath here, and I want you to write this definitely in your book and probably colour it in, the assumption, because these days in a maths exam you quite often have to explain your assumptions, the assumption is that in each bar all the people are equally spread out across the bar. We make the same assumption when we do box and whisker, because we were splitting boxes and whiskers up when we did that, and we assumed there that things were equally spread. This is the issue with having grouped data and losing your original values. Of course, if you could manage to get hold of the ages of all of the actual people on the bus, 29 people, you just go through your list and count them up, isn't it? But because it's been grouped into a table, we sort of have to make a few guesses about how they're spread out. So that's really important, okay? And quite often in an exam, you will have to sort of regurgitate that almost word for word. It'll say state any assumptions that you used answering the question. And our assumption was when we split the bar, that they were equally spread, so we got a 3/6 divide because I split it into 1/3 and 2/3 really, haven't I? Okay, so that's all you need to know about reading a histogram to get frequencies and splitting bars.